Hey all, welcome to a little conversation about variables in Java. So first things first, I'm going to create a new Java project to get things going. So here I have open an old project. I'm just going to go here, I'm going to click new, I'm going to click project. I'm going to call this project a lecture on variables. And I'm going to go ahead and create that with the version 21 of the JDK. And I'm going to go ahead and let this add some sample code for me. That just gives me a real basic starting point. And I want to open it in this window. Great. I've got a little bit of stuff here. So awesome. Okay. So I just want to check that this is working. The way I'm going to check that this is working is I'm just going to press the run button here, and we'll see that we've got some code that actually executes something. Great. It's printing hello world in the console. Cool. That's essentially what I want to start with. Okay. So we've got this public class main. We just kind of need that thing. That's really making a main class. Don't worry too much about what that is or does for right now. And then we've got this main method in here. That's what's actually going to kind of execute. So first things first, I want to start talking about creating variables. And the first variable I'm going to create is just going to be a string. And I'm going to say that this is a static string. We're going to talk a bunch about what the kind of optional modifiers are. Static just means that it belongs to the class itself and not to instances of the class. If that doesn't make any sense, don't sweat it. It doesn't honestly hella matter right now. But I want you to get used to either typing static or not with some intention. So I'm going to type static on everything we're going to do here because I really do intend these all to be owned by the main method or by the main class. And not by any of the instances of that class, which frankly I'm not going to create. So my first one's going to be called a static. It's going to be a string that's telling it what kind of thing am I creating. And I'm going to create a string that I'm going to call hello world. And I'm going to set this equal to, and I'm going to grab our hello world in quotes there, and I'm going to put a semicolon after that. Now, right now you'll notice that this is grayed out. And the reason that this is grayed out is that it's not used anywhere. You can see there's no usages afterwards. So let's get that thing used somewhere. So I'm going to put hello world right here. And now this name stands for this stuff. And that's really what a variable is. It's just a name that we use to stand for some stuff in the computer's memory. This stuff happens to be the words hello world with an exclamation point at the end and both capitalized with this comma in the middle. So it's those characters strung together. I'm going to hit run on this just to make sure that it's still working the same way it was before. Okay, great. Works exactly the same way. This way we could change what we mean by hello world at some point in the program, and it would go ahead and print out this same thing or the new version anytime we changed it. That's really kind of what a variable is good for. So this line here is making a string variable. So this is a string variable's declaration and initialization. So the declaration part of that is this bit, and the initialization part of that is this bit. So when we tell the computer what we're going to name a variable and what we're going to keep in it, that's us declaring a variable. And when we actually put something in it, that's called initializing. Some variables come pre-initialized to 0 or something. Strings don't happen to, so I went ahead and gave that some content. Let's go ahead and kind of think about some of this other stuff. These little guys, the double quotes, those have to be used for strings. If you're used to other programming languages, you might be able to get away with single quotes or double quotes. in Java, you can only use double quotes for strings. These single quotes are used for characters. So let's make a character. We'll make another static character, and the word or the abbreviation, the label for character is char, and I'm going to call this test character. And I'm going to go ahead and put an A in that thing, and you'll note I used single quotes for that. Let's take our little print line here, and let's print out our test character. And I'm hitting tab to autocomplete those when they start coming up. I'm going to hit run on this. Okay, so we got A as a character. It printed out. Let me show you the thing about the quotes mattering. So let's swap that to double quotes. Now it's raising an error. It's telling us that we should change our field type to string. In other words, that's the wrong quotes for a character. Maybe you meant to make this a string. Let's see that actually does cause an error. Okay, I got a new error for me. This is incompatible types. That's an error that's actually going to happen to us a lot. So it's telling us that it can't convert a string into a character. That's essentially, you tried to give me a word and I got a letter, and or I was expecting a letter and you tried to give me a word. I'm confused. So we're going to go ahead and just swap those back. We could try that same thought up here. We'd get a very similar error up here. So if we swap the double quotes to single quotes up there, we'll get that it's essentially too big to parse. It got too many letters. It was confused. So we'll go ahead and put those back. All right. So characters store a single, let's spell right. I can't type, I'm sorry. A single letter or a single character off the keyboard. So it's a bit weird to say that a character stores a single character, but really that's what's happening. So it can store punctuation marks, it can store numbers, it can store any emojis and crap. That's what a character is. It's like a single item. Should be noted there's some slight weirdness with these. Let's see. So the slight weirdness with these is say I wanted to do a static character. I'm going to call this one test character 2. And I'm going to make this one equal to 97. And then we're going to go ahead and we'll copy this and we'll print out test character 2. And that's going to come out to be A again. The reason it's coming out to be A again is A is the 97th character. We could quick swap this to 1 and see what the first character is. Obviously, the first character is that little dude, because of course it is, right? What else would it be? Don't be silly. I didn't make up this enumeration rule. Look, there's another little weird guy. There's a reason for this, but it's too old and too deep right now. If you want to dig deep into it, ask one of the AIs to explain to you why the character maps are the way they are. It's an interesting piece of history, but not one I want to deal with right at the moment. So that's another way to print A. We could loop through and get all the letters of the alphabet by going from 97, 98, 99, and so forth. That would be a solid option for seeing a bunch of characters. Let's see. Other things we learned are that strings take double quotes and characters take single quotes. Okay, what do you do if you want a single quote to appear in a hello world, or what if you want a double quote to appear in there? what you do is you use an escape character. So these guys are escapes. So that little backslash says this next character, don't treat it as though it's what it usually is in the compiler. Treat it as though it's just a character by itself. So if we hit run on this, we'll get world with double quotes on it. It's a little annoying to use these escape characters, but they're helpful in a lot of instances. So hopefully that makes sense. There's a bunch more of those. We'll get to some of them in a bit. For right now, that's what I want to chat about on them. Okay, let's see. So integers are a thing. Specifically, those are stuff like starting at -3, -2, -1, going to 0, going to 1, going to 2, going to 3, and going on and on. So essentially all of the counting numbers, 0, and the negative counting numbers are called the integers. We can just go ahead and declare those. So we declare those using int, and we can call this, we'll call this test int. And I'm going to make my test integer 17 because I like 17 as a number. It's kind of a weird size, it's prime. I'm getting a no usages notice here. Here I'm getting told to insert a semicolon, but I already did that, so I'm going to ignore that. Okay, so how do we print these out? We can go ahead and just use a print line like this. Oops, I guess we don't need, we can dump these guys. Okay, and it is yelling at me for some reason. Why is that yelling at me? Non-static field cannot be referenced. It's because I forgot to put the word static. Okay, so here we're in a static method, and this thing wasn't static, so because this guy's static, it couldn't get at that guy. But don't worry, we'll talk more about this later, but it happens sometimes. Okay, when I hit run, I'm going to see 17 there. That's not quite how I want to do this. So let's try out a new thing. So I'm going to try out a printf here. And what we're going to want to do is we're going to want to print out so printf is like a formatted string. Okay, so my formatted string is going to look like this. I'm going to write our integer is colon parenthesis, let's try an I there. We might be wrong. That's okay. What that letter is indicates what kind of variable it is. And then we'll do a %n, a quote, and a comma, and a space. Okay, what this thing is doing, this is telling us that I is an unknown string converter. So we're going to need to figure out what the right thing to put here is. Let's try a D. Let's see if that works. Okay. The D converter is go figure for is the way you print integers. If we wanted a float, we would put an F there. This D is for base 10 or decimal integer. This is an old inheritance thing that's not very convenient. Frankly, a thing that could be updated to make the Java language better, but at this point the Java language is old enough that that ain't going to change. The %n kicks us on to the next line. Oops, didn't mean to do that. Kicks us on to the next line. So our next print statement is actually going to end up on the next line instead of just stacked here afterwards. Okay, cool. So that's getting an integer out. If we wanted to do some kind of math with it, we could go ahead and do that here. We could go ahead and say our integer plus 23 is, and then we'd leave our %d and our %n, so that's saying we're going to put in the number that comes after this, right? The integer that comes after this, and then we're going to kick a new line. And here we're just going to do our little arithmetic here. We're going to tell it to take test integer plus 23. That's going to end up in this %d spot. And so we should see our integer plus 23 is 40. Cool. So you can go ahead and do a little math in these. It doesn't care. It'll very happily do a little math for you. Okay, so we've gotten strings, we've got characters, we've got integers. What else are there? Well, there's doubles. So are for decimals. There's two kinds of things that are for decimals. The default is going to be doubles. I kind of want you to just go ahead and make everything doubles. There's a reason that you might think about making things floats. So floats are also decimals. Doubles are 64-bit. What that means is they're stored in 64 pieces of memory that are either on or off. There's a mathematical reason for these sizes. Let's not sweat it right now, but that's a 64-bit, and a float is a decimal that is in fact a 32-bit. Integers, by the way, are they also happen to be 32-bit. There's a thing called a long that's just a 64-bit version of an integer. You can go ahead and use that if you for some reason have to. Do keep in mind, integers in mathematics can be any counting number between minus infinity and infinity, not including either of the infinities. In computer science, we're limited to the space we have in the RAM or the space we've allocated. And so for us, an integer is stuck between some value and minus some value. Those values are determined by the size of it. So there's a 32-bit, like there's the biggest number you can make in 32-bit. We'll talk more about exactly what that number is later. If you truly wanted to know, you can do integer.max to figure it out. I wouldn't. I'm not going to say it's super useful right now, so I'm going to kind of skip it. If you want to investigate that a little bit on your own, feel free. It's not going to hurt you to understand it, and it's basically comprehensible. I'm going to make a static. Final double, and final means that I'm never going to modify that later in the code. Like I'm not going to change the value. I haven't been intending to change the value of any of these, but I could have. This one we're not going to be able to. And the reason for that is that I'm going to store pi in this one. So our static final double pi is, let's do 3.14151926 in there. That's our version of pi. It's yelling at us about not having any usage there. Let's go ahead and get that printing out. So I'm going to just grab this line, and I'm going to change this from our integer is to pi is. Oops. Stop it. I'm going to change it to pi is. And then I'm going to need to change this D to an F. And here we're going to put pi in. Okay, and so we should see right here, pi is 3.141596. Great. Let's hit go and see if we indeed see that. Okay, cool. All right, so that's telling us what pi is, which is great. What if I wanted to do some kind of, I don't know, like what if I wanted to manipulate this thing a little bit? Like, what if I wanted to round pi a little bit? There's a way to round relatively coarsely. So there are better ways to accomplish this. I want to be really clear that what this is doing is this is going to take all of the values after the decimal and throw them away. What that means is that if I do this with a negative number, it's going to round up. If I do it with a positive number, it's going to round down. That does create some weirdness. For rounding, there's a round function in the math library. There's also a ceiling function, which rounds everything up, and a floor function, which rounds everything down. But typecasting is important, and so I just want you to know that it's possible. So I'm going to call this pi as an integer is. I'm going to swap this f for a d. And here I'm going to put some parentheses, and I'm going to put int. And that's going to tell it force pi to be an integer. So this thing here is what's called a typecast. So I'm going to put that here because it sounds magical and awesome. And I'm going to write here, it rounds negative numbers up and positive numbers down. And then I'm going to write a little, I'm going to write a C also math dot ceiling math dot floor and math dot round is the other one. Okay, so let's hit run on this and see what happens here. We've got pi as an integer is 3, and that's actually an integer now, which means that I can treat it like an integer. I can add it to an integer. I'm still going to get an integer. There's some advantages here. Most of our random number stuff is going to deal in terms of floats or doubles, and if you want to take a random number and then do something with it, you often want to take it and somehow turn it into an integer. You can use floor or ceiling or this integer casting to do that. Kind of any of them will work pretty reasonably. Do please note that those have slightly different behaviors though, so make sure you're picking the one that's appropriate to the situation you're trying to work on. So let's talk about just a couple other things. The last variable type that I want to really mention is a Boolean. So I'm going to make a static Boolean here. So we're going to say I want to make a static Boolean. Oops, not a Boolean, a Boolean, and I'm going to call this thing test Boolean. And my test Boolean, I'm going to start out as true. Now, there's a little bit of weirdness here. Because a Boolean is either true or false, it should amount to a single transistor's value, right? Either on or off. In Java, that should be a bit. A bit is one transistor being either on or off. So let me maybe add this. Philosophically, this should be a bit. Realistically, they're basically never a bit. So what they are depends on the specific way that the Java virtual machine works. We haven't talked about the Java virtual machine at all. So depends basically on how the computer you're pushing run on is set up. These can be up to 32 bits. I believe in a couple implementations they may even be 64 bits. 32 bits is the same size as an integer. So they may be using the full power of an integer to describe a single bit, which is a lot. There's ways that this gets slimmed down. When you put them in an array or inside an object, sometimes there's some optimization that happens. But generally speaking, they are way bigger than they feel like they ought to be. And you do have to be a little cognizant of dealing with that. This can cause some really serious memory management issues if you're working on really specific hardware. I just mention this because it should be a thought in your mind that Booleans aren't quite as efficient as they might seem.
If you shove them in an array, they get pretty efficient, though. So it can be up to 32 bits. And then I'm going to put in parentheses here 64 bits? Question mark. We'll talk a little bit more about bit math at some point here, but not for right now. So let's go ahead and print that guy out. Sorry, office assistant got a little excited there. Okay, so let's print out that Boolean. So what we're going to do is we're going to go ahead and grab one of our formatted string print lines. And I'm just going to say our Boolean is, and here we're going to use a B. And I'm going to try to print this and just see what happens. Why is it saying true right there? That's a bit confusing, right? It's interpreting pi as a Boolean as true. Let me go ahead and put in our test Boolean there. Okay. And our test Boolean also is true. If I make our test Boolean false, our test Boolean is now printing out as false. So here's a little brain teaser for you. See if you can think up why it is that it A, didn't throw an error when I tried to print out pi as a Boolean, and then B, figure out why that version of pi counts as true. That should be a little bit, well, should be a little bit hard to explain, honestly. I don't think it's beyond you guys. It might be a fairly tough question right now. If you want to flag this one for us to talk about in class, feel free to do that, and we can have a slightly deeper discussion on that. I want to kind of finish our thought process here with a couple other things. So first thing first, I just want to show you what all of the possible variable types are. These are all the basic ones. So here's all the basic variable types, and this little thingamajig is a multi-line comment. So comments are code that doesn't get executed. You've seen me making these guys this whole time. Those are just like notes to myself. Here's what we can do to make a multi-line comment. And we can see, all right, we didn't talk about bytes. Shorts are a smaller version of an integer. Long is a bigger version of an integer. Floats and doubles are both decimals, floats being smaller than doubles. Strings we talked about, those are like basically like philosophically words or something. A character is like philosophically a single character. A Boolean is a single true or false value. And then let's talk about kind of misrepresenting stuff. So I'm going to, in order to misrepresent some stuff here, I'm going to go ahead and right here at the bottom, I'm going to make pi as a string. This is a thing that's going to happen to you when you collect user input. You're going to get your user, they're going to type something in on the keyboard, and it's going to automatically get turned into a string by the program, and then you're going to want to try to interpret it as something else. So what I'm going to do is I'm going to say, let's make a static string pi as string. And we're going to go ahead and make this equal to 3.14, but in quotes. So this thing's not going to act like a number. Let me show you what I mean by that. So let's go down here a little bit, and let's do a, let me just grab one of these guys. So I'm going to go ahead and grab this, and I'm going to say pi as a string is, and in order to print it out here, we'll need an S to print out our string, and we'll need to put in our pi as a string there. So when we hit run, we should see here pi as a string is 3.14. Great, that's all working. Okay, let's try modifying that line just slightly. So we'll do pi as a string plus 1 is, and we'll put a plus 1 there. Let's go ahead and run this and see what happens. Okay, it didn't really do what I was expecting it to do. I was kind of expecting it to give me 4.14, and it took that 1 that I tried to add and stuck it at the end. This operation is called string concatenation. So concatenation is where you just take the letters and kind of shove them back to back with each other. So that's not real convenient because I wanted it to do math and it did string stuff. So if I want it to do math, I need to convert it to a decimal before I do that addition. So let's take this guy and we'll try that again. So pi as a string converted to a decimal plus 1 is, and then here I need to convert this guy. So the way we're going to convert this guy is we're going to do double dot parse double, and then we're going to put our pi as a string in there. So what's going on here is we're saying, all right, go into the double class, grab the parse double method, and please feed that thing, so use that function or that method on pi as a string. So that's going to take our pi as a string, our 3.14, which is with our double quotes on it, and then it's going to feed it into a thing that turns stuff into doubles. So I'm basically feeding this guy into the double method. We could use a typecast for this. This is really not typecasting is a really, frankly, kind of a dangerous and bad idea. This is a slightly better version of a typecast. I'm still going to refer to this basically as a typecast. It's a little bit more complicated than a typecast. It's actually a parsing. But I'm probably going to, when I talk to you guys about this, I'm going to call that a typecast. So let's see what actually happens here. Okay, so we got 4.14, and what the shit is that? Okay, what the shit that is that is because computers are doing math with rocks that think. Right, a computer is essentially a whole bunch of narrowly sliced rocks that we tricked into thinking for us, and that stuff thinks in base 2, and this is a base 2 problem. These don't really go away, although you can kind of fake it a bit. Java's not going to try to fake it for you. It's going to go ahead and give you this nonsense, and the reason this nonsense is happening is something to do with the way numbers are stored in there. Don't worry, we're going to delve into this quite a bit, but I'll do that probably in an in-person lecture. Okay, this is what I want you guys to take from today. Oh, one more thing. Sorry, I lied. Last thing. Let's investigate those biggest and smallest an integers can be. So I'm just going to grab a couple lines out of my notes here, and I'm going to drop them in here. These are the largest an integer can be and the smallest an integer can be. The largest an integer can be and the largest a long can be. So let's see those. So here's our integer here, and here's our long here. So longs can be quite a bit bigger than integers. Let's go ahead and take both of these guys. And we'll copy these, and let's see if min value is a thing. Certainly looks like it is. Okay, so let's hit run. And you might notice that these aren't quite symmetrical, right? The biggest an integer can be, those should be the smallest. Not smallest, smallest. Okay, so notice that the largest an integer can be here is this number that ends in a 7, and the smallest it can be is this number here that ends in an 8. Otherwise, those numbers are the same. They're just off by 1. And the reason for that is we had to pick a side to put 0 on, and we use a first bit to decide whether it's positive or negative. So there's 31 storage bits for an integer and 1 sign bit. And the one that's all zeros is in fact 0. So the 0 counts as a positive number for this. So we have one fewer kind of obvious positive numbers than we have negative numbers because 0 counts as positive. This is not really here or there, just an interesting tidbit about the language. And that's what I've got for you guys tonight. So thank you for watching, and use your new powers wisely.